This question asks us to identify the alkene which, when treated with HBr, will form this product. There are actually 3 correct answers to this particular problem. Let's go ahead and look at them. We start with our cycloheptane. We have the 2 methyl groups on the bottom left. We'll put one on a wedge, one on a dash. And we have another methyl group at this position. One of the possible alkenes could be the alkene here. This would react with HBr to form a carbocation the bromide would attack, and we'd get our product. Another possibility would also be from a cycloheptane ring, again with our 2 dimethyl groups, and again with the methyl group. This time, though, the alkene could be on the other side. This is a different molecule. If we named this, the alkene would be in different positions. It would react with HBr to form a carbocation. Br- would attack, and we get the same product. The third possibility would again be from a cycloheptane, again with our dimethyl groups, and again with our methyl group, this time with the alkene sticking out into the methyl group, an exocyclic alkene. This alkene would react with HBr, put a carbocation at this position, bromide would attack, and we'd get our final product. Any one of these 3 alkenes would give us this bromide upon treatment with HBr.